I'm going to go ahead and start presenting and recording early. I mean, it's not early. We're actually almost 10 minutes behind schedule, but it's Tuesday, and Tuesday sucks. So we'll just start as we need to. All right. One thing I want to talk about is announcements. And let me find my announcements. As you all know, the last day of class is November 24th. So you need to write all this stuff down so y'all don't ask these stupid questions the next week. All right, so the last day of class is on the 24th. On Tuesday, the 24th, these things will happen. Your final exam and your last test will start. Your final exam and your last test will end on December 7th. What is going to be your last test? Your last test is going to be logs. Okay? I'm going to get logs in before Tuesday. I'm going to start today. Okay? So, final exam and your log test will start on the 24th and end on the 7th. That's about 2 weeks. Homework will terminate on 11/24. Now, since I am doing logs a little bit later, I'm going to shut down the log homework on the 7th. So your log homework will probably end on the 7th because that'll give you a little bit more than 2 weeks to finish the log homework. Okay, so let's put down log homework will end on the 7th. Right, excuse me. So on the 7th, your log homework, your final exam, and your last test on logs will finish on the 7th, midnight. So make sure you give yourself plenty of time. If you're working on homework for the logs, make sure you give yourself plenty of time to take the final exam and the last test. Your final exam will be 2 attempts and probably 25 to 33 questions. They will be all math questions, no bonus questions. They will come from your old test, which you can go into your gradebook and review. There's a review link right beside your Chapter 1 test, Chapter 2 test, or whatever, and you can review that material. I usually make the test a 1-hour test, and I give you 2 hours. So that gives everybody double the amount of time to take the test. I do not give you 2 hours worth of questions. Now, if you want me to, I will. But I think it's more fair to give everybody a 1-hour test and give them 2 hours to do it. And remember that the log homework and not the log homework, but the final exam and the log test will start on the 24th. The log homework will be open before then. And they will all end. The log homework, the log test, and the final exam will end on the 7th. That's 2 weeks, about 2 weeks. Also, if you see something funny on My Labs Plus, go with it. Don't write me an email and say you're confused. If you see something on My Labs Plus that might help you, take advantage of it. Do not write me an email that says, Hubert, I'm confused over something I saw on My Labs Plus. Just go with it. Any questions? Any Hemi questions? That's to cover all the spazzing out questions at the end of the week, at the end of the semester. So does that cover all the spazzing out questions? Somebody say yes or no. So I know you don't want to talk to me, but somebody say yes or no. Does anybody, y'all just not talking to me today? Okay. Miss Hollister, will you talk to me? Does that answer some of your
Yeah,
questions?
that covered everything. I think everyone shouldn't be confused anymore.
Okay. There'll be somebody.
Yeah, there's always that one person.
There's always a deadhead.
Okay, now homework questions. We'll get these homework questions out of the way so y'all can finish chapter 4. And these are some simple homework questions. They're not that involved. So 4.131/11. 4.131/11. I think I know what happened on this problem because it's usually normally this is what students do. They count these dots and they think, oh, that's 3, and it's not, it's 6. And that's what happened on this one. You got a horizontal shift of 4 to the left, so that would be a positive 4. And then you have 6 down, 2, 4, 6. And that'd be 6 down. What students do here is they count over 2, and they'll put a 2 plus 2 here, and then they'll put a minus 3 here. That's what students make. They make a mistake. They just count the dots. They don't count the quantity. So this is a good test question. Very good test question. So make sure you make a note of this one because it'll be on the test. But make sure you don't count the dots. You count the quantity. So that would be positive 4 and negative 6, not positive 2 and negative 3. Okay? That's a good test question. Next one. 4.219/8. 4.219/8. All right, I'm going to do the first one. Well, I'll do them real quick because I want to try to get through. I want to try to get started on logs today. F of x is equal to 4x minus 8 over 5. And g of x is equal to 5x plus 8 over 4. And f composed of g. Well, f means that I'm going to rewrite f with a big set of parentheses. 4 times parentheses minus 8 over 5. And g means that I'm going to plug in g. And now I'll just do my algebra. So somebody tell me what happens to the 4s. They cancel, Hubert. That's right, class. Thank you for the interaction. I appreciate it. 5x plus 8 minus 8 over 5. 5x over 5 is x. So f composed of g is x. G composed of f. G.
You have a work email.
Composed of f. So that means I'm going to rewrite g with a BA set of parentheses. Five times parentheses plus 8 over 4. And plug in f. 4x minus 8 over 5. And of course, the 5's cancel. And you're left with 4x minus 8 plus 8. 4x over 4 is x. That's a good test question. Next. 4221/9. Another good test question. Okay, Mr. Spradlin, you need to mute that mic, man. You sound like you're in Star Trek or something. All right. F of x is equal to 5x squared. G of x is equal to x minus 8 over 2. They want f composed of g of 4 and g composed of f of -2. Well, the first thing you're going to do is rewrite f with a big set of parentheses and stick in x minus 8 over 2. And that's going to give you x minus 8 squared. Good gosh, yuck. That's going to give you x minus 8 quantity squared over 4. And that's going to give you, well, we can go ahead and stick in the 4. And that's going to be 4 5x times 4 minus 8 quantity squared over 4. And that's going to give you 5 times 4 minus 8 is -4. That's 16 over 4 is 4. I say 20. But they might want you to expand that x minus 8 squared. Let's see if we get 20. Yep. And now we're going to rewrite g with a big set of parentheses and plug in 5x squared.
Hubert, can you go to your piece of paper?
Oh, sorry. And plug in 5x squared. And that's going to be 5x squared minus 8 over 2. And plug in a -2. 5 times -2 squared minus 8 over 2. 5 times -2 squared is 4. That's 20. 20 minus 8 is what? 12. And 12 over 2 is 6. Let me type in 6 and check it. Good test question. At least you're picking some good questions. Those are some good questions for test. Okay. All right. Next one. Heck, John. Sound like you're coming out from under the earth, Miss Hollister. Sound like you're coming through the ground. Or somebody. 4.225/10. Okay, this is a question about profit. And remember, before you even start this problem, profit is equal to the revenue minus the cost. Always remember that, okay? Profit is always equal to the revenue minus the cost. All right, what do they give us? they give us the cost is that and the revenue is that. So profit is equal to 81x minus 19x plus 4371. And 81 minus 20 is 61. So that'd be 62. Somebody check my math. Would that be 62 minus 4371? Somebody check 81 minus 19 for me.
Yes, that's right. It's 62.
Okay. So this is your profit formula equation, profit equation. I think that's what they're asking for. What is the profit on the production of 200 bicycles? Well, P of 200 is equal to 62 times 200 minus 4371. Take your handy dandy calculator, which I got to move this to find my calculator. There we go. And make that small and move this over. Things I do for y'all. 200 times 62 minus 4371. Dadgum, $8,029. So they got a profit of $8,029. So P of X is equal to 62X minus 4371. And the profit is 8,029. Write the function that gives the average profit. Well, anytime you want the average profit, you take the profit and divide by X. Now, they don't tell you this crap, so you have to learn it. So I'm going to go over here, and anytime you want to find the average profit, you take your profit equation and divide by X. So that would be 62X minus 4371 divided by X divided by X. And that would be 62 minus 4371 over X. And that's your average profit. What is that noise, Mr. Spradlin? Sound like you're in an auditorium. And you don't want to talk to me. 62 minus 4371 over X. Well, I don't know what it is then, if it's not. Whatever. As y'all see, that's the same thing. The average profit per bicycle, I guess you plug the 200 in there. So that's going to be, if they want 200. So 62 times 200, which you could just divide your last answer by 200. It's whatever. Minus 4371. And divide that by 200. $40.15. So each bike is $40.15 profit. And you feel good about yourself. So anytime you want the average profit, just divide the profit equation by X, or take your profit and divide by the number of bikes. Okay, either one of those will work. You could have took that 8,029 and divide by 200, and that would have gave you the same thing as this. So either way you want to do it's fine with me. I probably wouldn't put that on a test. If I did put this on a test, it would be just 1. So unless it was the same type question, that would just be extra points. So if I did put this on a test, it would be 1. Next, 4.2, 31/13. Okay, same type question. If the monthly cost of producing 27-inch, blah, 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 then the average cost would be blah, 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 blah. Explain how C of X and other functions can be combined to obtain the average cost function. Well, you take your total amount of profit and divide by the number of items. That's pretty self-explanatory. And now, there you go. Okay. Dividing the function by X. Oh, that was hard. And now type in 700. So I'm going to take my handy dandy calculator. And we're going to do 107 times 7,000. Wow. I'm sure that's right. Okay, 40,000 minus second answer. That doesn't look right. Divided by 7,000. That don't look right. 101.28. That'd be a negative. That's a loss. I don't understand what I did wrong. Make sure I read the question right. If the total cost producing 27 inches, okay, that's that. Where X is the number of sets produced per month. Average cost per set. If 7,000 sets are produced. Okay, I've done something wrong. Anybody got a clue? Average cost per unit.
No, I'm lost.
What is the average? What?
I'm lost.
What is the average cost per set? If 7,000. Okay, I don't understand what they're doing. There's that. We know that. I'm not worried about that. You divide by X. We already established that. Oh, I know what I did wrong. I subtracted. I thought that was a subtraction symbol. I don't know why I subtracted. I'm sorry.
You have a work
I knew
email.
something was wrong. All right, let me go back. See, I subtracted 40,000 plus 749,000. So 749,000, sorry, 749,000 plus 40,000 equals divided by 7,000. There we go, 112.71. 112.71. Make sure you read your positive. That I don't know why I thought that was negative. I have no idea. I guess I'm just on drugs or something. I don't know. And that's it. All right, next one. 4.25/3. Another composition or adding and subtracting. So here we go. F of x is equal to 6 over x. G of x is equal to x plus 1 over 5. And they want to know f plus g of x. This is a test question. Well, you're going to take 6 over x and you're going to add it to x plus 1 over 5. Now you could get a common denominator of 5x. X will go into 5x 5 times. 5 times 6 is 30. 5 will go into 5x. X times x plus 1 is x squared plus x. And that's going to give you x squared plus x plus 30 over 5x. So you could either get that answer or this answer. I don't know how far they want to take it. I'm just going to type in 3. They wanted you to take it all the way. So they wanted you to do x squared plus x plus 30. Got to get a common denominator. X will go into 5x. 5 times 6 is 30. 5 will go into 5x. X times x is x squared. X times 1 is x. All right, now f minus g of x. Well, that's going to be 6 over x minus x plus 1 over 5. Get a common denominator of 5x again. And that's going to give you 30 minus, and I'm going to put this in parentheses because that's a minus. And that's going to be x squared plus x. Oops. And then you're going to distribute that negative. That's going to give you negative x squared minus x plus 30 over 5x. Unless I made a mistake in there, it should be a minus. Okay, negative x squared minus x plus 30 over 5x. F times g. So I'm going to put f times g of x is going to be 6 over x times x plus 1 over 5. And that's going to give me 6 times x plus 1 over 5x. Now, they may go 6x plus 6 over 5x, so I'm going to go ahead and write it. 6x plus 6 over 5x. Either one of those are correct. Sorry. So I'm going to type a 3 in here. I'll bring that back so you can look at it. And this is a test question, so you better make sure you know how to do this one. F divided by G. F divided by G of X is equal to 6 over X divided by X plus 1 over 5. What do you do when you divide by a fraction? What do you do when you divide by a fraction?
You can multiply them if you flip
Multiply by the what?
it.
Reciprocal.
Reciprocal, that's the word.
So that's going to be 30 over X squared plus X. Now, they didn't do the X squared plus X, but I'll take both answers. X times X plus 1 or X squared plus X. What is the domain of F divided by G? Well, you got to set the denominator equal to 0 because you can't have 0 in the denominator. So this is E. X squared plus X is equal to 0. X times X plus 1 is equal to 0. So you can't have 0 or -1 in the denominator. So your domain is all real numbers except you cannot use 0 and -1. You cannot use X cannot equal 0 and -1. So your domain is going to be from -infinity to 0, non-inclusive, and then from 0 to -1, non-inclusive, and then from -1 to infinity, all non-inclusive. I'm not going to write all that. I'm just going to type in a 3. And -infinity to -1, non-inclusive, -1 to 0, and then 0 to infinity. I might have had it backwards, I'm sorry. That's a good test question. Leave that up for a couple of seconds for the 1 or 2 people that's going to watch the video so they can pause it. Next one, 4.29/4. Oh, me oh my, another one. F of X is equal to X squared minus 3X. G of X is equal to 4 minus X cubed. And they want you to do F plus G, and then plug in a -2. So F plus G is going to be X squared minus 3X plus 4 minus X cubed. And that's going to give you nothing really. -X cubed plus X squared minus 3X plus 4. And plug in a -2 and for that. And that's going to be cubed plus -2 squared minus 3 times -2 plus 4. Well, -2 cubed is -8. -8 with a negative in front of it is +8. Plus 4 plus 6 plus 4. Y'all check me. 6 plus 4 is 10. And 10 plus 12 is 22. I got 22. Let's see if it's right. Ding. All right, now let's do F, G minus F. G minus F of 1. G is 4 minus x cubed minus x squared minus 3x. 4 minus x cubed minus x squared plus 3x. And of course, there's nothing to combine, so you just go ahead and evaluate at 1. And that's going to give you 4 minus 1 cubed minus 1 squared plus 3 times 1. Oh, man, excuse me. And that's going to be 4. Negative 1 cubed is negative 1. Negative 1, because that negative, I don't think that negative is squared, so I'm going to leave that a negative, plus 3. 4 minus 1 is 2. 2 plus 3 is 5. Now, I may have the wrong answer by 1 because of that plus 1. I put in a negative 1, but I believe that's supposed to be a negative 1 because it's not parentheses. But we'll see. It's either 5 or, let's see, 4 minus 1 is 3. 3 plus 1 is 4. 4 plus 3. It's either 5 or 7. There we go. F times G of 2. F times G of 2. So F is x squared minus 3x times 4 minus x cubed. 4x squared minus x to the 5th minus 12x plus 3x cubed. Yuck. So, negative x to the 5th plus 3x cubed plus 4x squared minus 12x. And they want to plug in a 2. Well, 2 to the 5th power is 32, so that's going to be negative 32 plus 2 to the 3rd power is 8. 8 times 3 is 24. 2 times 2 is 4, that's 16, minus 24. Well, the 24s cancel. And that leaves you with negative 32 plus 16 to be negative 16. Well, I'll see what they got. I might have one thing. They got 8, so I don't know what I did wrong. Let me check that. Negative 32, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. That's right. 3 to the 2nd power, 2 to the 3rd power is 8. 8 times 3 is 24. 2 to the 2nd power is 4. 4 times 4 is 16. And 2 be negative 24. I don't know what I could have got. I don't know what's wrong. Negative 32 plus 24. I believe that's 8. Negative 8 plus 16 is positive 8. And positive 8 minus 24, I still get negative 16. I think the answer is negative 16 on that one. Somebody check me and see if you get 8. I get negative 16. Let's check the last one. G divided by F. And you're going to put a negative 2 in there. So that's going to be G, which is 4 minus x cubed, divided by x squared minus 3x. Well, there's really nothing you can do here. You can't divide them. So you just plug and chug. So 4 minus negative 2 cubed over negative 2 squared minus 3 times negative 2. And negative 2 cubed is negative 8. Minus a negative 8 is plus 8. So that's going to be 4 plus 8.
Have a work email.
And then 2 squared is 4. And negative 3 times negative 2 is positive 6. And that's going to be 4 plus 8 is 12 over 10, which is equal to what? 6 over 5? Six divided by 5. Yeah, I think, did anybody try that one, see again? Did anybody get a different answer? And nobody's going to
I'm
talk to
working
me.
on it.
What did you get, Mr. Melnick?
I'm still working on it.
Okay. Delete. 4.3 11/5. 4.3 11/5. Determine whether the function is 1-to-1. It's not. Somebody tell me why. Why is it not 1-to-1? I want y'all to answer. I want somebody to answer or just say, I don't know.
I do not know.
Okay, 1-to-1, what does that mean? For each x, there's a y. Not doubled. 1-to-1 means that you don't have double numbers. Is this one 1-to-1? Does it have for every x, there's a single, a different y? No.
Oh, okay. I see now.
2 9s. See those 2 9s? It's not 1-to-1. If all the numbers are different, and the x's and the y's, and there's no repeats, then it's a 1-to-1. That's a test question because it's short and sweet.
Yeah, I like your explanation better than how they try to do it.
Yeah. 4.335/15. Okay. A function that converts pounds of country A to dollars of country B is given by f of x is equal to 1.9732x. And they're going to want to know the inverse. So y is equal to 1.9732x. Change the x and the y. Divide, oh, that's a y. And divide by 1.9732. So y inverse is going to be equal to x over 1.9732. And that's going to be the dollars from country B into the pounds of country A. So x divided by 19732. And that's converting dollars from B to pounds from A. All right, multiply, do this formula, and then take that number and put it in, and you should come out with 3,000 at the end. So let's check it. So 3,000 times 19732. 1.9732 times, what did it say? 3,000. So that's,
By the way,
I'm
for that
sorry,
one
what?
question, I did get 16, negative 16.
Okay, so I'm right. I think they're wrong. All right, 59,196. So now when you plug 59,196 and divide it by 1.9732, 1.9732, you should get 3,000. And that's what they're asking. 3,000. I don't like that as a test question. I like the first part. I like A as a test question, but I don't like the rest of it. (4.39/4). Now this one is not hard because remember what I told you about inverses on the graph? What is special about the inverses, the graph of the inverses? What did I tell you about x and y on one function? What does it do on the other function?
The opposite?
It's just the opposite.
Exactly. So if you got a -3 here, a -4, and a 19 here, it's going to turn around here and here. So this would be -3. This would be -2. This would be -1. And this would be 0. And over here would be -15, -11, 7, and -3. Now that's a good test question. Why is that a good test question? Because you don't have to do anything. All you have to do is think about what is an inverse. An inverse, the x and the y's switch places. And that's the homework questions. Okay. I think I got all of them. All right. So if you look on your file that I sent you today, I sent y'all a file and I can't find it. So I go to files. And it should be called Logarithms or something. Did I send y'all a file? Exponents and logs. Everybody see that? Sent it 5 hours ago. Give y'all plenty of time to look at it and print it. Of course, I'm only talking to 5 or 6 people, because the rest of y'all don't check any of this stuff. So you're just lost, like Patrick Starr. I think I got it down here. Yeah. Now, most of y'all know the exponential laws for your product rule. I want you to look over that right quick. And most of y'all know that. Go ahead and look over it. Product rule, what do you do with the exponents when you multiply and the bases are the same? You add the exponents. What do you do if you divide and the bases are the same? You subtract the exponents. That should bring back memories. What do you do when you raise a power to a power? You multiply the exponents, and so on. Okay, now, everybody should know these exponential laws. I'm not going to spend a lot of time on this. I do want you to be able to add to your parent graphs, be able to add y is equal to 2 to the x power. Two to the x power. Make sure you add that to your parent graphs, and I'll show you why. F of x is equal to 2 to the x power. And that looks like this, crosses at 0, 1, like that. And I can give you f of x is equal to the x plus 3 minus 1. Somebody tell me what's going on here. Come on, somebody talk. I'm not going to go until you say something. What's going on with this guy?
Is there a shift?
Okay, keep going. What is it? Horizontal shift is what? Vertical shift is what?
-1.
Down 1. What's the horizontal shift?
Would it be, I don't know, x plus 3, or is it just 3?
3 to the what?
To the right.
What is the horizontal shift always?
To the left?
It's always the opposite.
Yeah, I'm bad at this.
That's all right, Mr. Milnick. We counted you out a long time ago. I gave you a
Yeah,
W a long time ago. So you can just forget it. All right. So now that we have a 3 to the left, 1, 2, 3, and 1 down. So now that sucker's going like that. So make sure you apply your positive and negative vertical shifts to this parent graph. Remember, I told you to leave a couple of slots open on your parent graph. You know, the graph that I told you to divide your paper and got a linear, got a parabola, got a squiggle, got a wider parabola, which is a quartic, and a wider, and then I told you to do an absolute value, and I told you to do a square root, and then I told you to do, I think we went over the rational, and then the volcano, and then this one, which is like that. And the next one is going to be the logarithm. And logarithm looks like this. Kind of like the square root, but it's shallower. Okay, so if you remember your parent graphs, you should have all these. Okay, and I just told you to add that one. This one right here, 2 to the x power. It is the inverse of the log of x. Let me show you a trick I learned in the war. Take this handy dandy calculator, and now I'm going to do y is equal to the log of x. And then I'm going to add in yellow the dashed light colored line x and graph. Look there. And if you can't see it, we're going to zoom in. See? From here on, and from about here up this way, they're symmetrical around the oblique asymptote, which is that yellow line. And you can bet your bottom dollar that the x and the y on the blue line is going to be the y and the x on the magenta line. Now, that leads us to this. The bridge between exponents and logarithms. This one right here, this sentence right here, if you don't learn this sentence right here that I'm marking, let's see, can I highlight this? No. If you don't learn that sentence called the definition of a logarithm, you might as well not even take the test, because that is the basis for everything we're doing. Okay, so I'm going to write it down just in case you don't see it. The definition of a logarithm: y is equal to log base a of x. And you can rewrite the logarithm as a exponent. X is equal a to the y. You can write a fraction as a logarithm, or you can write a logarithm as a fraction. And this is called the definition of a log. So if I give you an exponent, you should be able to write it as a logarithm. If I give you a logarithm, you should be able to write it as an exponent. Now, these three things that I'm giving you should be written on a index card, or you should take these and shrink them down a little bit and put them on index cards, because they're very, very, very important. That's why I'm showing it to you first before we even get into logarithms. We're going to get into them, but you got to know them before you learn them, if that makes sense. You got to know about them, and you got to know of them before we start to learn them. Okay, so that's that. And then here are your logarithmic properties. Write those down. That's your third card. Ooh-wee. Now, if you notice, there is a similarity between the product rule and the quotient rule and the power rule with the exponential rules. That's because logarithms are glorified exponents. Now there's one rule up here with the exponents I want you to add. And they never show it. And that is when you have the same base for an exponent. Add this to your exponential laws. If you have two, well, let's go with 16 to the x power is equal to 2 to the 4th power. Okay? In order to do a problem like this, you got to have the same base. Okay? So you've got to change that 16 to 2 to the 4th power. And that 2 to the 4th power to the x power, using the power rule, can change to 2 to the 4x is equal to 2 to the 4. Now the rule I'm fixing to show you is the same as the logarithmic rule, only it's the exponential rule. If the bases are the same, somebody tell me what you can do to the exponents. I'm waiting for somebody to say either I don't know or tell me the answer. It's called communication. It's not very hard.
Can't you multiply them?
Well, not multiply them, but set them what?
Equal.
Equal to each other. Since the bases are the same, take the exponents and set them equal to each other and solve. So x is equal to the 1st power. This right here is what I want you to write down on your index card. If the bases are the same, you can set the exponents equal to each other. So that would be a to the n equals a to the m. N is equal to m. That's what you would write down. If the bases are the same, then you can set the denominators, the exponents equal to each other. Now, why do I bring that up? Because on this logarithm, you have that rule right there. If the bases are the same, see the base a and a, if they're the same, then you can set x equal to y. Question, right, complaint. Hopefully you won't bog down on logarithms because they're not that difficult. But the problem is students try to do logarithms without knowing or having these 3 important pieces of information with them. So make sure you either copy this page for the test or in homework, or you make a card an index card, it'd be 3 index cards, or technically front and back, and you could put this at the very top of one, because that's the only thing important out of all this is that definition of logarithm right there. So you don't need this whole half a page right here. Question, great, complaint. Okay. So let's look at, I don't forgot the section. What is it 6? I think it's 6, isn't it? Is it chapter 6 logarithms or is it 5? Which one is it?
It's 5.
Okay, so we're only going to do 5.1 through 5. So you need to mark that down. 5.1 through 5.4. And that's what you're responsible for up until the last day of class.
Can you show us where that file is on my labs?
Yeah.
Because I couldn't find it.
It's not on my labs. It's on Teams.
Oh, okay. That explains why I couldn't find it.
Right here. That's all right. Miss Hollister, you are communicating. And that's why you're going to have a big office when you get out in the career world, you're going to have a big office. It's going to be very nice. And people are going to come in and talk to you. And all these other people, they're going to be in closets. They're going to be in closet offices. And nobody's going to talk to them. They're going to think they're weird or something. Because they don't talk, they don't communicate. They're extroverted. I mean, introverted. Right, gang? Yeah. Like I said.
Right.
Yeah. Right. 15 minutes later. Yeah. Yeah, man. Yeah. .1 should be logarithms. They might start with a little bit of exponentials, and there it is right there. I already showed you that one. That is well, as I said, it's the alter ego of logarithm, okay? You've got y is equal to 2 to the x. The inverse of that is log of x. There's horizontal shift. X plus 4, x minus 4 is a negative, so that means it's 3 to the right. And I use that 0, 1 point. That's the point I use to move to the right. So it's kind of hard to move these because you don't know where they are. But you know that 0, 1, if you move 3, 4 to the right, then that's going to be 4, 1. 4, 1 is coinciding with 0, 1. So if you can find that 1 right there on this one, then you just move it over. I don't see logarithms yet. The exponential, you do use exponentials when you're talking about business. See, there's an exponential right there. A number raised to the t power. These are called exponential growth models. I'm looking to see if there's anything really No, not really. I don't see anything very important except what I've already shown you. I'm looking. Don't worry, we'll do more examples Thursday. I just want to get to the logarithms. Okay, they must go introduce them in the next section. Hold on. 5.2. There we go. And they're going to start you off with the definition of a logarithm. There it is. Y is equal to log base b of x is defined by x is equal to b to the y. Now, we've already written that down because you got it on your sheet. It's called the definition of a logarithm. And that's it. So there's some examples right there. Let's see if they're going to do it the right way. Okay, so you could write these down because these are examples of the definition of a logarithm. Here's what you're given. You're given 3 to the second power is equal to 9. That's called an exponential. So you can change an exponential to a logarithm. Log base 3 of 9 is equal to 2. I'm going to give you a minute to write those down for examples. And it goes the other way also. You could be given a logarithm and they tell you to write it as a exponent.
Priority 1 message coming in on secured channel. Gmail.
Okay. Now you can easily go the other way. And these are 3 examples of going the other way. All 7, 8 of these questions are test questions for the definition of a logarithm. So while you're doing y is equal to log base a of x yields a to the y is equal to x. Go ahead and write those 3 down. So I'm just going to take log base 2 16 is equal to 4. And on the previous problem, I'm going to do 5 or 4 to the negative 1 is equal to 1/4. Okay, here's the two problems that I'm choosing. Okay, right now this one looks like this one over here. So I'm going to put my 4 here, my -1 here, and my 1/4 here. And I got A is equal to 4, Y is equal to -1, and X is equal to 1/4. Now what I do with those three things after I ascertain what they are, what I do with them? Plug and what? Plug and chug, Hubert. So that's -1 is equal to log base A of 1/4. And that's how you do it. Over here, this one looks like this. So I'll just write it. Y is equal to log base A of X. So A is equal to 2, X is equal to 16, and Y is equal to 4. And what I do with those three things? Plug in what? A to the Y is equal to 16. Plug and chug. But if you don't know this, if you don't have it on a card, or if you don't memorize it, you might as well not even do the test. Because not only is this in rewriting, but it's also in solving equations. And there's three things that I want you to know before we quit with this unit. One, I want you to be able to, graph logs versus exponents. I want you to be able to rewrite using the definition of a logarithm and properties like we're doing right here. We'll do properties next. And 3, solve equations. That's the only thing that I'm concerned with before this test. I want you to be able to do those 3 things. And this is number 2, starting number 2. I'm rewriting a logarithm of an exponent as a logarithm, and I'm rewriting a logarithm as an exponent. So we're rewriting, and there's 3 other properties that go with this as far as rewriting. And you use all of them with solving equations. So hopefully I'll get into solving equations Thursday and Tuesday. As you can see, a lot of this is just plug and chug. Let me get to the properties. That's what I want to get to. Oh, shoot. 6-4. Is that where we were? I done lost where we were. There we go. Okay, graph, log base 5 of X. Well, you do that in your calculator, but you can't do it without the change base formula. Write this down. It's only the change base formula. The change base formula is what you use when you don't have a LOG, which is log base E, LOG, which is log base 10, or natural log, which is log base E. This right here is the only thing your calculator knows. Okay? LOG that's the key, LOG on your calculator. That's log base 10. The natural log key is log base E. Calculator cannot do log base 5. Okay, unless it's a newer calculator that has the programming to do that. Okay, so what you do is you use the change base formula, and the change base formula says log base b of a number a. I can change that to log base e or 10 of a over log base e or 10 of b. So I can rewrite any, that's log base 10 or natural log of a over natural log of b, that's log base e. So in this problem, they only give us the base 5. Okay, well, technically, calculators can't do base 5, so you got to change it. Log base 5 of x is equal to the log of x over the log of 5, or natural log of x over natural log of 5. That's called the change base formula. Now you can put that in your calculator and you can graph it. I will not ask you to graph a exponential or a logarithm by hand on a calculator. On a test. I will ask you to sketch using the vertical and horizontal shifts. I'll show you that in just a second. Calculator. And let's see, when is class over? I don't have my, oh shoot, I don't have my list in front of me. When's class over? 11. I don't trust some of y'all. Miss, darn, she done left. I guess she has. I guess Miss Hollister, what time's class over?
I think it's over at 11.
Okay, well, we're over. So let me just do this right quick. So y is equal to clear, clear, and clear. And I'm going to do parentheses, log of x, close parentheses, divided by log of 5, and graph. There it is. So what I told you, this right here, when I told you graph log versus exponents, that means with the calculator and with vertical / horizontal shifting. You should be able to do both of those for graphing. Okay, that's enough for today. Let me get the roll and shut down the recorder.